Welcome everyone. This is Training and AutoML Walkthrough Community Call on 5th of February. This meeting will be recorded and published on YouTube, and this meeting is governed by the Kubeflow Code of Conduct. Maybe we can. So today we have a really great call. We have a few demos and discussions, exciting discussions around new proposals. But first of all, I just want to spend 5 minutes for new folks to just introduce themselves. Who just want to go next to introduce themselves to the community? Just want to say hello.
Hey, can I go in?
Yeah, go ahead. Go ahead, sir.
Yeah, hi folks, I'm Siddharth. I'm a final year student. I'm a enthusiast at open source. I've been contributing to Internet Archive and I've been in the Kubeflow meetings for a while. And yeah, I think I've been uh, part of Cube Day and local CNCF meetups, and that is how I got to know about Kubeflow. And yeah, super excited to be here. I'm just uh, really enthusiastic to learn more about the project, and yeah, that is something about me.
Thanks for joining. Thank you. Welcome to the
Thank
community.
you.
Who wanna go next? Yeah, feel free to jump in. Yeah, in any case, I think feel free to just add your name to the comment to the agenda. Let us know about yourself and how we can help you, especially with the new contributors. Looking forward to work with all of you in this GSOC and even outside of the GSOC to see how we can improve the Qflow components moving forward. So yeah, just maybe let's before we jump to the JAX demo from Sandipan, I just want to quickly share a few things around the release. So we finally released the Qflow Training Operator 1.9.0. Let me share my screen. Um, so this is the final tech. This is a great release for us that it has a lot of features like introducing the JAX support that we will speak about in a few minutes, and also like the manage by API, which allows us to orchestrate training jobs across multi-clusters. Also, it has a lot of great features for SDK, bug fixes, and the trainer v2, of course, integrations. So please take a look, try this release. Let us know if you see any problems or issues with this. We're going to maintain this release for a while. Like even that's if we're planning to have more minor, like releases on the release branch 1.9, because we're gonna have like this long period of time when we're going to migrate users to the Qflow Trainer v2, which will take some time from us. Any questions for the training operator release?
So one question. So
Mm.
um actually today we fixed permission issue, right?
Yeah.
For the P1.9. So is there any plan to cut a new tag or not? I'm okay with either way. So I just want to ask community if we need to cut new tag for the permissions bug fixes.
Yeah, I guess like the problem is like the manifest is being synced only with text, right? So we need to cut the RC one. Do we have any other PRs that we want to, any other bug fixes we want to merge to this release branch?
I do not have any PRs for bug fixes.
Yeah, if not, like, like we can just cut the RC. The thing is like I don't want to cut RC if we identify more bugs, right? Like we need to cut another RC because this is just the YAML fix, right? Um, yeah,
Yeah.
let me, yeah. Um, So can you maybe take a look like if there are any other pending PRs that we have, like some bug fixes that we can merge, like for example this one, like for MPI job, or any other PRs that could be open, or you think we should be ready to go with the RC1?
Oh, I see. So what is the deadline for the PL?
Yeah, I think manifest I think is like going on until March, right? Like actually last week of February. So we have some time to discuss it. Yeah, let me ping Julius again to see like if we actually need to cut RC or they can just synchronize it without RC, right? And
Yeah, yeah, sounds great.
any other bug fix that we want to include, let me know. Like but maybe we should just share pick them to the release branch as well. Like I saw this PR, for example, which is introducing the QPS similar to training operator, right? Sorry, the NP operator. Um, so let me make the note here.
I think this is only for training operator beats trainer beats.
This is V1 actually. Sorry, this QPS is for V1.
Oh, I see.
Yeah, so I think I found these two PRs that we might want to cherry pick, right? Um, so it would be nice
Yeah,
if we
sure.
could, take a look at this. Right, should we move on?
Yes.
Okay, so for KD, I think like we need to release 0.18 today, right? So Xiao, do you think we can merge this PR today? Like, or it requires more review from our side?
It, it may require more review.
Mm-hmm.
Yeah. First, my suggestion was to create a separate issue, and create more description in the user document to take care that Optuna algorithm only supports uniform and log uniform.
Okay.
Yeah. And I think we just have this PR that need to merge.
Okay, in that case, I would suggest can we cut RC0 and then, like we can maybe cut RC1 for some time. I didn't get a chance to review up to changes as well. So,
Yeah, maybe we can finish it in today.
okay. What do you think, Yuki? Like, does it sound good to you? Like,
Yeah, sounds good.
okay.
And we can move the end-to-end test for TuneAPI and Optuna, and maybe Go Optuna. If I remember correctly, in Shashank's JSON core, we still need to implement another another algorithm, and we can put them together in the RC1.
Yeah, I think that would be nice. If we can do it. Uh, all right. Do we have any other pending PRs for before we can cut RC?
I think maybe we already merged all the important PRs, and the remaining you can check the roadmap and pull down
This one, right?
and pull down. Yeah. And we almost merged all the important fixes and features, and the two remaining PRs in the roadmap, Optuna and end-to-end test, we can merge it in the RC1. So I
Okay.
think it's good. It's okay to cut RC0 today.
All right. All right. Sounds good. Any other questions for KD release?
Yeah, hi Andre, this is Shashank. Yeah, so I reached out to someone in Optuna regarding if they are going to add support for normal distribution soon.
Mm-hmm.
So they mentioned about some method, so I'm looking into it. So maybe we could implement normal distribution in Optuna also. Uh, but that would be possible after RC0, I guess.
Yeah, can you create a tracking issue for it? I think that would be nice. So,
Yeah, sure.
so Shashank, like in terms of having a changes in RC1, that does it look good to you? Because I think we need like a few more days to review a PR, right? Even without the normal distribution for Optuna.
Yeah, I think we can finish it without normal distribution, I guess.
Yeah,
And
yeah.
Shao said that we can add it to the documentation for the grid algorithm for uptuning.
Yeah, but the tricky part, like I didn't get the chance to. I mean, I can try to review it today after this call. But like if not, like I think we should do it in RC1. Let me try to take a look like after this call if we have any. Because we have some pending questions, right? Uh, I think we still from Shao, right, and from Magdi, right? Uh,
Yeah.
on this PR. Did you address these changes that they ask you to do?
Yeah, I addressed the changes, but
Okay.
I think Mahdi also couldn't figure out exactly where to change so that we could support the double parameter in for the grid algorithm. So if you take a look after the call.
Okay. Yeah, sure. That sounds good. Any other comments? Like, what do you think? Like, from your perspective, like, should we release it? Try to release it today? Like,
Yeah, yeah. Mm. Yeah, I think so. There's no remaining tasks for cutting projects, right?
yeah, it's only this PR, right, that it needs to review the 2446.
Yeah, but so I cannot guarantee to finalize review within this week. Yeah.
Okay, let me try to take a look after this call. If I think we need more time, we can just cut RC and cherry pick this PR to RC1, right?
Yeah,
Sure.
sounds great.
Yeah.
Okay. Yeah, any other questions for KTP release so we can move to the demo?
No other questions for me.
All right. So then in that case, feel free to share your screen, Sanipan, and just walk us through the JAX demo.
Yeah, sure. Hey everyone, my name is Sandipan Panda and I am from India. So during the Google Summer of Code 2024, I had the opportunity to contribute to the Kubeflow project by working on the integration of JAX with Kubeflow training operator. The goal of this project was to provide a seamless and efficient way to run distributed computations on CPU using the JAX framework on Kubernetes. So throughout the summer, I worked to build out this feature by extending the training operator. So, brief project overview of JAX. So, JAX is a powerful machine learning framework developed by Google, and it is highly valued for its flexibility and performance in large scale distributed computations, especially with its native support for automatic differentiation and hardware accelerators like GPUs and TPUs. The Kubeflow training operator, as you all know, is a popular Kubernetes component that allows users to run distributed ML training jobs across various frameworks such as TensorFlow, PyTorch, XGBoost. However, until now, it lacked direct support for JAX. So the motivation for this project was that uh, as JAX supports distributed computations across multiple devices like CPUs, GPUs, and TPUs using multiprocess setups, and it is designed for data parallelism using the SPDM or single program multiple data model. And by integrating JAX with the Kubeflow training operator, we can simplify fine tuning and scalable distributed training of machine learning models on Kubernetes that are created using JAX. So the goal of this project was to create a new custom resource definitions called JAX job for managing JAX distributed training jobs on Kubernetes, and update the training operator to controller to support JAX jobs like it has already support for TensorFlow jobs, PyTorch job, and XGBoost job. and implement webhook validations for JAX job and add example and documentation to demonstrate the JAX job. So just let me talk briefly about running multiprocess computations on JAX. So launching JAX processes is a bit different. Unlike other distributed systems where a single controller node manages many worker nodes, JAX uses a multi-controller programming model where each JAX Python process runs independently, sometimes referred to as single program multiple data model. Generally, the same JAX Python program is run in each process with only slight differences between each process execution. Example, different processes will load different input data. Furthermore, we have to keep in mind that we must manually run our JAX program on each host, as JAX does not automatically start multiple process from a single program invocation. So to initialize the JAX distributed training, we have to use the JAX distributed initialize API, which allows JAX processes to discover each other and share topology information. Performs It also performs health checking, and it is used for distributed checkpointing. And here are some mandatory parameters that is needed to provide to JAX distributed initialize API. They are coordinator address, num processes, and process ID. Coordinator address is the IP address of process 0 in our cluster, together with a port available on that process. So process 0 will start a JAX service exposed via that IP address and port, to which the other processes in the cluster will connect. And number processes is the number of processes in the cluster, and process ID is the ID number of this process. So just let me now go briefly through a demo of how we can run a JAX distributed training on Kubeflow training operator. So we have this data set that is basically we have adapted from the Google JAX a SPDM minist classifier from scratch, and we have a data set where, and from that we create here two workers. And note that we for JAX we don't need any master nodes, only two worker nodes, and the worker node 0 is the process 0 for JAX, and this is what the from where JAX distributed initialize API will get the coordinator address. And this is an example of the minst example that we are trying to demonstrate. So here first we import JAX and the related modules, and here is the tricky part. So we did not have a GPU support to test out the JAX distributed training, so we had to adapt this example so we can run multiprocess uh, uh, JAX on CPU. So normally JAX will treat a CPU as a single device by default, regardless of the number of cores available. This means that PMAP is not possible out of the box, so we'll need to instruct JAX to split the CPU into multiple devices. So this variable we have to set that before JAX or any other library is imported. So after we have imported the data sets here, and then we have to specify that glue. We are using glue as the communication framework for communication between the various processes. Glue is a distributed communication library that is used for collective operations in multiprocess settings. So here we get the process ID, num process, and coordinator address from the pods. And here we initialize the JAX distributed execution. In the next step here, we initialize neural network parameters. And then we define the model's forward pass, define the loss function, uh, define the accuracy metrics, and here we prepare the data in the training setup. So like here we are defining a three-layer neural network with a input layer with 748 neurons and two hidden layers with 1024 neurons each, and an outer layer with 10 neurons for classification. So here is the data pipeline. It generally creates mini batches for training, ensuring the batch size is evenly divisible across devices. Uh, and here it is the SPDM parallel training setup with PMAP. So PMAP is basically, the purpose of PMAP is to express SPDM programs. Applying PMAP to a function will compile the function with XLA and then execute it in parallel on XLA devices such as multiple GPUs or multiple TPU cores. Uh, so here we replicate the parameters across devices, and this is the training loop. It runs training for num epochs and updating the parameters via PMAP, and evaluates training, test, and accuracy. So we have run this example here, so it just takes some time. So I have run it beforehand so that it doesn't take much time to show the demo. Uh, so here we are applying the SPDM minst example job, and we can see that the JAX job minst is successfully created, and then we get two ports as we defined here, uh, two worker pods. JAX job means worker 0 and worker 2, they are running and completed. And if we inspect the logs of the worker pods, here we can see that my CPU is with 8 cores and we are running two JAX worker processes with the XLA configuration here. So here we have, so for that we have total device count for JAX is 16 and local device count is 8 for 8 CPU cores process, and the means example epoch is run successfully as you can see here. And so this is like the demo. So for the project summary, the my work involved first creating the JAX integration enhancement proposal, and then I created a new Kubernetes custom resource for JAX and updated the training operator controller to support JAX job, and then implemented webhook validations and unit testing and integration testing, and updated the user documentation to demonstrate JAX job. And apart from that, I also added Kubeflow subprojects to CLO monitor. So CLO monitor is a project by CNCF, which just basically checks that an project follows certain open source security based practices. And the future work on this is adding JAX training runtime for Kubeflow training version 2 API. The work on it is currently going on. So with that, integrating JAX with the Kubeflow training operator has been a challenging but rewarding experience. Uh, so throughout this project, I gained valuable insights into distributed systems, Kubernetes resource management, and the inner workings of machine learning frameworks like JAX. And some key takeaways was I deepened my understanding of Kubernetes, particularly TRDs and controllers, which are like the backbone of extending Kubernetes functionality. And working in a collaborative environment with experienced mentors was one of the highlights. And their feedback and guidance helped me improve not only my technical skills and but also my ability to communicate and collaborate effectively. And this project gave me a deeper appreciation for the complexities of distributed training and the importance of tools like Kubernetes in managing large scale machine learning workloads. So I'm grateful to my mentors, Andre, you throughout this summer, and I look forward to seeing how this feature evolves and benefits the Keyflow community in the future. And shout out to Silas, I guess, for helping fix some issues that we are facing with integrating the JAX SPDM example with the CI for Keyflow training operator. And with that, I will stop presenting, and that's all for now. So thank you so much to the Keyflow community and my mentors for giving me this opportunity.
Yeah, I think this is great. Thank you so much, Sandipan, for this presentation, sharing the work. I think this was one of the most requested feature from users for almost 4 years. We're really looking for feedback from customers and users who want to try this on TPUs, and especially it's cheaper, faster, and easier for them to do this on Kubernetes. Any questions from community that you want to ask to Sandipan about the work? I maybe want to ask if you get a chance to explore when folks should use JAX over PyTorch or any other framework. And I understand it could be useful for TPUs, right? But did you get any chance of compare metrics and utilization across multiple different ML frameworks?
So I didn't get the opportunity to look much into this in detail. Uh, so I just need to work on that.
Yeah, I think that would be really nice to see, because I guess the problem that we see that sometimes MLEs they're not really expert in distributed computing, right? So they probably they just want to use what is available, what is cheaper for them, and how they can quickly prototype with their ML development. I think we as a community should recommend them and suggest when they should use this and that technology, right? Because we have a lot of expertise, in different areas, and I think it will be helpful to see those metrics and benchmarks um, as well, right? Um, yeah, because I think there is a the problem is there are so many different frameworks, and folks just don't know what they should use in which use cases, right? Um, the one thing that I noticed that JAX is pretty scalable compared to GPUs. So it's relatively easy for Google to give you more TPU, for you to scale your training across more TPU devices compared to GPU devices. But every TPU device will be less less powerful. compared to GPU. Which means like for some use cases, if you really need to scale your training and you don't need to have a lot of power on a single hardware, I think that will be really useful for your models. But I know I didn't go deeply into details, like for example, like all these foundational models when they've been trained on JAX, whether versus PyTorch, or like versus any other framework today. Do we know? Do I have any kind of knowledge from the community here, like who've been experimenting with these frameworks? Um,
Sorry,
like yeah,
what was the question again?
yeah, like when folks decide, want to use TPUs and JAX over, like over PyTorch, XLA or GPUs, right?
Yeah, that one I don't like. I've never actually used TPUs or worked anywhere that has used TPUs. So like off the cuff, my intuition would say that like probably only people that are exploring it and then find that they like it and the experience is easy enough. But I think you know, so that might be folks on GCP heavily. A lot of folks I know are on AWS though. So, but I could be wrong.
Yeah. Would be nice to get the feedback, especially from the end users on the GKey, right? Like because I think the scale, and I think it would be nice to compare the cost, right? Like to see when you should use this technology. Yeah, go ahead, Yuki.
So actually, I have another question. So, okay.
Yeah, go ahead.
So my question is, the current JAX job can be used by higher level JAX framework like DeepMind, Haiku, or and so on.
Yeah, I think it's an interesting question. Sunny, but you try to explore, like, there is kind of like, I think, abstractions on top of JAX. I think you mentioned about this, right? The DM Haiku. I didn't explore it before. Do you know, Sunny, about anything about these frameworks? If that could be used, like in JAX job can be used there as well.
So I have heard about many frameworks that are being developed by Google on top of JAX, but I haven't tested out that they work with the Kubeflow training operator yet. So that's a nice pointer, and I will try looking into it. Thanks for pointing me to that.
Yeah, I think as long as they use the same kind of, environments, right, for distributed communication, I think it should work, right? Similar to PyTorch Lightning.
Yes.
Like PyTorch Lightning, I think you still you can use Torch Run with PyTorch Lightning. Yeah, so definitely like you can like is there any benefits to using Haiku over normal JAX? Just a simplification, or it has some other features like deep speed on top?
Yeah, not sure. So if we should verify this compatibility in upstream any code level or testing level. Yeah, but so I just want to point out more higher layer library because so I think researchers mostly use higher level API instead of directly using JAX, right? Yeah, but yeah, so I think if we can yeah if we can put any example or documentations for the actual real cases for JAX in our upstream repository, yeah, it would be great, I think. Yeah, this is that's my comment. Yeah.
Yeah, absolutely. I think once we build the runtime for JAX job in V2, I think we can also try to see like, how we can build different runtimes to support those frameworks, right? And offer data scientists even easier API for them to play with, right? Yeah. Any
Yeah,
other
sounds
questions?
great.
Yeah. Any other questions from the community? All right. So thanks again for your work, Sanipan. I guess like it would be also I think very nice if we can share this with broader community call sometimes maybe in a few weeks. So folks also get know like what we've been doing for the last year in terms of supporting Jax. And I guess like I know we already have some pending issue to support Jack's job within queue. I can share this pending issue. Yeah, but I would love to see more adoption in terms of usability and how we can like make it easier for folks to do distribute training on top.
Yeah, actually, so we Q community is currently trying to support Jack's job in upstream KQ control manager. Yeah, but so the problem is we are not sure if current Jack's job completely support NVIDIA GPU or NCCL corrective communications, right?
Yeah, we need to verify GPU at least. And the TPU also would be nice to verify if anyone has infrastructure for it.
Yeah. Currently, we verified only GRU corrective communication. Yeah. I think so. Before we verify the NICU support behavior, so I think so we can move Q Rebel supporting forward in Q repositories. Yeah, so I think so we can collaborate with between Q and training operator in the Jax or Jax job supporting. Yeah.
Yep. Yeah, I think that sounds good. All right. Should we move on? Or any other last comments? All right. So in that case, let me share my screen. Yeah. So we have two topics to discuss, right? We have this LLM trainer cap that Xiao like prepared, and we need to definitely review it and move forward. And also have that SDK proposal. So Xiao, from your perspective, like what do you think we should talk first? Like on SDK side, I don't expect a lot of discussions here. Yeah, go
I
ahead.
just need 3 minutes to have a quick recap into the PR.
Okay. Yeah. Do you want to like walk us quickly through the proposal, and then we can jump to the SDK discussion then?
Yeah, I will share my screen. Can you see my screen?
Yep.
Yeah. My hi community. This is a KEP for the Kubeflow LM trainer. Yeah, you can check it here in the 2410. And we will collect the final community feedback by the February maybe 20th and start the implementation after that. And my open question is that we adopt the Torch-run as a launcher for the LM trainer. We discussed it before. And now my question is, do we need to support more launchers like Pertune maybe in the future, or Hugging Face Accelerate in the future? That's a question one. And another question is, do we want to support adaptive prone tuning and prefix tuning? This is not so common as LoRa or QLoRa, but I think we may need to support it as well, since Llama receives the fine-tuning recipes for Llama support adapter prompt. Yeah, do we? So my question is, do we really need to support it? And what I update is in the KPs I designed the workflow of the trainer. Yeah, since we decide to use the Torch-run to launch it, then we will use Torch-run to launch the trainer, and the trainer is manipulated by a job set. And the model initializer and data initializer will provide model and data set for the for the LM channel and load it into the PVC. And our LM channel will do the pre-process work for the pre-process the data set for the users, but the pre-process logic need to defined by some data set, or we may need to store some built-in data sets class, and we also allow users to define their own pre-processed logic and pass it into the SDK. And we decide to support multiple fine-tuning frameworks such as Hugging Face transformers and native PyTorch and NVIDIA NeMo. So users can choose from these three frameworks to fine-tune their models. And then finally, after the fine-tuning, users can use a model exporter to export model to the cloud storage. That is a basic workflow of Chainer, and I'm looking forward to the feedbacks from the community. Yeah, please review this PR.
Yeah, so I definitely need to take a look. Thank you again, Shao, for this. I think we definitely need to have like some examples of trainer in your cap, like at least how the Hugging Face trainer will look like, right? So because we're going to use, we don't have accelerator support today in our framework, right?
Yeah,
So can you just maybe give some sample examples how you can use DDP and FSDP with Hugging Face trainer? In that case,
yeah,
yeah.
yeah. I will add it.
Yeah, so I guess like we need to like decide also like there is supervised fine tuning trainer, right? SFT trainer, and also the
Yeah,
default trainer from Hugging Face. So which one we want to start first, right? Um,
yeah.
and how it's going to work with Torch Run.
So do you mean I need to implement a prototype and demonstrate it to the community?
Yeah, maybe add some code samples similar to how you've done for multi-framework support, right? You added this, backends that I think Dipankar was working on, right? Um,
Yeah, I see.
so if we initially just support Hugging Face trainer, right, with the X amount of parameters user can configure, um, and for this we will use torch run as a start command, right? Um,
Yeah,
we will we be able to actually use FSDP plus DDP, actually only
yeah,
FSDP for like fine tuning? I think this is what we need to take a look. Um,
yeah.
you can go ahead.
Yeah, so I have one question for the diagram. Um, so I mean, so I indicated second diagram. So yeah,
Is
yeah,
this
this one.
diagram?
So
Yeah,
yeah, this one. So in this diagram, so what exactly mean? So rancher. So I mean, so rancher indicates any container or user performed CLI.
launcher means that what we use to start the training script, such as torch run, as torch run. And somebody use Python, somebody use torch run, and may somebody use accelerate or torch tune. Yeah, the launcher. Yeah, go on.
I see. In that case, so this launcher is performed within any container, right?
Yeah,
I see. In that case, so why this launcher is outside of job set?
maybe I need to update the diagram.
I
Yeah,
see. Okay. Yeah.
yeah,
So
yeah.
no worries. So I just wanted to um
Yes.
confirm if my understanding correctly. Yeah. So yeah, I guess so. This launcher is performed in the job set replicated job with indice index 0, maybe, right? Yeah.
Yeah.
Yeah. Okay. Sounds good. Thank you.
Yeah, so basically it's multiple pods, right? And the job set actually creating these pods, right? Using this launch command, right? So you probably need to adjust this diagram a little bit.
Yeah. Maybe I need to update my diagram.
Yeah.
It's sounds
Yeah.
misleading.
I think that we also need to talk about, so from my understanding, users of this feature, they don't really care about the launching commands as they care about like what they want to do, right? Because this feature just for folks who want to quickly fine tune, use our blueprints to fine
Yeah.
tune models, right? They don't really care about what we use underneath, right? They probably
But
want, yeah.
it may have significant difference between the torch 1 and torch 2 if we decide to adopt torch 2.
Yeah, I think I'm asking. I'm talking about different things. So the things about framework, I don't think users of this feature care about framework as they care about
Yeah.
like what model and data set they want to use, right? Um,
Yeah.
that is why again, I think it's good for us to have an options for folks to choose NVIDIA Nemo or Hugging Face or anything else. Um, but I think we should identify the best frameworks we can choose to fine tune those models in the most efficient way, right? Like for example, why deep speed exists. I don't like an expert there, but I guess like because FSDP is the complicated technology, and FSDP kind of like helps you to optimize it, right? Because deep speed is built on top of PyTorch, and it has additional like features to advance, like basically provide more, like sophisticated distributed technique on top of FSDP. Yeah, but overall, like I guess like from the user perspective, I think they less care about framework, but more care about parameters that they can tweak. Um,
Yeah. So do you mean we need only support one framework for users and what we concern most is the theft or the sharding policies that is user faced.
yeah. Yeah. I mean, we can definitely have multiple trainers, right? But I think we shouldn't use multiple trainers to fine tune the same model, right? At least initially, right? So imagine we're gonna have like several blueprints to fine tune Llama. Maybe like we can take like Llama, I don't know, DeepSeek, like Mistral, what else? Like some popular models, right? We
Yeah.
use one framework, one trainer to fine tune them and see how it's going to work, right?
Do you mean that we need to create different trainer for different models?
I
Or do
think
we need to create a
eventually, I
unified
think
one?
eventually we should. I don't think. I mean, Hugging Face say they can fine tune anything with their trainer, but I mean, there is a. I mean, the other frameworks also exist, right? Because there are
Yeah.
some use cases when you might want to use them, right? Um, yeah,
I want
yeah. Go ahead, Joe. Yeah.
I wonder if we can unify these frameworks into one trainer and one trainer to train several models, such as we only implement one trainer, and we can fine tune Llama, DeepSeek, and other models.
I think this is what we tried to do initially, right? Uh, like the multiple backend support. Like Dipankar, since you're on the call, can you explain a bit why do you want to support this use case?
Because I see like enterprises require this feature that suppose there is NVIDIA Indian model, so probably it's better trained using the NVIDIA Nemo framework.
But do we need to expose these parameters to users? Because again, SDK users that data scientists they don't really aware of all those complicated things around distributed compute, right? They only care about, how to fine tune my LLM.
So if we don't expose the parameters specifically required by NeMo, then how will we trigger NVIDIA NeMo?
Can we identify the parameters which is common across all these fine-tuning, experiments? Like, like for example, we have hyperparameters, right? We have lower parameters, right? Like which could be common across all these frameworks. Like, do we see any similarity between those different, using NVIDIA NeMo, using transformers, Hugging Face trainer, I mean?
But why do we want to give a single set of parameters? Like if we just in the documentation, like we can provide, right, that NVIDIA NeMo requires these set of parameters.
But do we want users to know about it? Like the question is.
I think oh sorry, Yuki says that hand up.
Yeah, you can maybe, yeah. Do you want to go first? Yuki?
Yeah. So I think so. I want to say the similar opinion as Andre. So I think so. We want to decouple of Python API and training runtime API because so I mean so I think so. Which fine-tuning Python library want to use depends on the user use cases. So it's challenging to support all API in our Python SDK API level. So ideally, so as Andre mentioned, so we want to extract common arguments and support those in Python API. So we want to we want to add training runtime for each Python fine-tuning library like Tortirun or NVIDIA NeMo or some else. So this is my opinion.
Yeah, that is why we hide this complexity of torch run, right? User doesn't want about rendezvous. User doesn't know like what is, how they group those workers, right? So they only care about like the minimal set of APIs they can tweak, right? Like it's kind of like I would say they less care about like torch.distribute API, but more care about torch.nn APIs, right? If that makes sense. I know that users still need to use them right now because we don't have these kind of abstractions for torch.dist API, distribute API, right? But I think we need to move towards this kind of simplification. Yeah, go ahead. Francisco, do you want to say something on your premise side? Like, what do you think?
Oh, yeah. I mean, I wasn't super familiar with Nemo before, and I just took a brief look. But so I do agree with the general point that like our end users shouldn't have to care. They should focus on the model, the neural architecture, their training loops for their losses, and to the degree possible, we should abstract that for them, and probably at that like. The YAML configurations of setting things up is probably what happens, and someone just passes them a config of like some default parameters that they need to put in. And so just, I think that the simple intuition for me always is like whatever's going to be easiest them for like to copy and paste a YAML around, sometimes even in a Jupyter notebook is probably what they'll do. And so, just making sure that we can enable them to be successful with that behavior and not judging it is probably the thing that I would encourage us to focus on.
Yeah, and they also have an options to like for more power users to build, do everything by yourself, right?
Exactly. Yeah.
Yeah.
Exactly.
Like they can even not use this trainer, they can use kind of like the, function-driven approach, right? Where we can just have an initializer script and then define a full fine-tuning loop in their, training function. This is possible, right? So this is more about like, for us as the community to choose the right set of tools, you need to use like a blueprint, right? Is like this is why I said about blueprint. Like what you need to use to fine-tune this model. And I can tweak some parameters, right? Like, like LoRa config or, like some hyperparameters like learning rates, right? Or other things. Does make sense to you, Dipankar, or you have different thoughts here?
Yeah, it
Yeah, I
makes
agree
sense to
that
me.
there should be like a certain set of defaults Uh, For
Yes.
example, if I
Good.
just share my screen just for 2 minutes. Can I share my screen?
Yeah. So if you stop sharing your screen, you can quickly share the bunker.
Yeah.
So I just asked ChatGPT like which are the parameters which are common. So these max steps, max epochs, these are common. So we can keep them as common. Like this every framework will require, but some these are different. So we can set these parameters as default. And so suppose this is missing in Nemo but present in Hugging Face. So
Yeah,
we can
that
set
makes,
the
yeah.
defaults, right?
Yes. So yeah, I think like that makes sense. Some of the parameters might be common, some of the parameters like mixed precision might be specific to the framework. Yes, but I think it's up to us to provide like the instructions for users to explain when they can use them, right? But I think maybe we should start with something small, right? Like with something very easy and then expand it, right? Um, because like I would love to understand like when you need to use these frameworks, right, over another, right? Like for which type of model, and will it be faster and cheaper for you? Um, yes, I think in the proposal maybe we should identify these kind of common parameters, right? Um, and then try to see how we can adjust it. Um, yeah, but because I don't think we should actually create multiple trainers for the same model, right? Like, should have one blueprint. I don't know, maybe in the future that will be changed, but I don't know if we need to support multiple trainers for the same model, right? Like multiple blueprints for the same model.
Like maybe we can start with the Hugging Face trainer and like
Yeah.
because it's simple and like generally Nemo is used for very large scale training, but for experimentations and all that, I think Hugging Face trainer is good.
Yes, let's start with this. Let's try to with very small number of parameters user can tweak. I know we already have fine-tuner config right in our SDK. So we start with something. I think Shao, like if you can add in the proposal, like if we use Torch Run as a launcher, right? Can you just still do FSDP within the Hugging Face trainer, right? And how
Yeah. Yeah, I will add this as some examples.
All right. Yeah, no over time. So I know we haven't discussed the SDK, but any kind of last questions, comments on this topic? I will try to take a look on the cap as well, just to provide the feedback on this. But let's try to see like what specific things we want to give to the user. And for the user persona we're talking about, again, it's not power user. It's more kind of a user who just want to quickly fine-tune those LLMs, right? Who probably just want to, experiment, right? And we provide them a template they can quickly use and plug in their data. On the data side, I think we also need to talk about like, which data we're allowed to plug in, right? Because I know there is some discussion around, like different format of the data and other topics, right? So anyway, so I think for SDK, let's follow up offline. Francisco, I still need to review other comments from you and other folks there, okay? And let's continue discussion offline. Like for anyone here on the call who like not aware, we're starting this proposal to create a unified Kubeflow Python SDK for data scientists and ML engineers. And if you want to be involved, just please take a look on this Google Doc that I shared in the notes. All right. Any last questions, comments? Sounds great. And so see you in 2 weeks. And please let me know in the offline if you need if you have any questions or if you need to follow up for these topics as well. All right. Thanks everyone. Thanks for the great demo and see you soon. See you in 2 weeks.
See you soon.